So we've taken a look at the pathogenesis of atherosclerosis and how a plaque can build up and what happens in terms of the tunica intima when a plaque builds up. We're going to take a look at now is what happens when we have some sort of dysfunction to that plaque. As we mentioned before, you don't really see any negative consequences to that plaque as it initially develops. Usually when we're seeing plaque formation, we know that a lot of the accumulation of foam cells and smooth muscle cells and inflammation occurs outward or occurs towards the tunica externa. So we don't actually have a lot of impedance into the lumen until the plaque becomes quite big. That doesn't mean that we're not going to see things like hypertension developing, but we're not having the severe occlusion to lumen size or that decrease in blood flow that is significant in acute pathology. So what happens when we talk about acute pathology is one of three things is going to happen to our plaque. So we'll just recap what's happening in terms of atherosclerosis and the pathogenesis of atherosclerosis, and we'll talk about what can happen to our fibrous cap or to the basically only membrane that's preventing this plaque formation from spilling into our lumen. So again, what's happened is someone that has had a risk factor or multiple risk factors that's leading to the formation of a plaque within the arterial lining. So we know that this plaque formation is stimulated by the presence of adhesion molecules on our vascular endothelium, which is going to lead to monocyte adhesion. So we know our monocyte adheres to that endothelial lining and sends some cell signaling into the cell, which leads to this migration of smooth muscle, right? So we see smooth muscles migrating to the tunica intima and building up in this tunica intima. We know that that's going to lead to inflammation. So these orange lines here are inflammatory response. So we know that we're seeing inflammation occurring as a result of this monocyte activation or adherence to the endothelium. And we also see the formation of foam cells. So monocytes actually make their way into the tunica intima. They engulf this LDL and they form lipid-laden foam cells, and they begin to live in that tunica intima and are part of that plaque formation. We know that one of the things that's happening after this as well is we get a sticky extracellular matrix forming, which promotes further infiltration of LDL molecules. And this process is going to be quite cyclic until we have the formation of quite a large plaque. So when these things are happening, what happens is cells start to die. We have basically the products of cell death. We have foam cells, inflammatory mediators, and smooth muscle cells that are forming a hard plaque. As this plaque pushes out into the vascular endothelium, what we see is damage to that endothelial lining, and it becomes thin and fibrous. So we see kind of a dense collagen network, but a very thin fibrous cap forms. So now instead of having a endothelium that is living and live and able to repair itself, we have a fibrous cap that has been repaired and is actually quite fragile. Now, one of three things can happen for us to have kind of negative consequence associated with this plaque. So the most common thing and the most common consequence that's going to cause acute pathology is we're going to have plaque rupture. And that's what we're going to focus on today. So we have plaque rupture. The second thing that we can have is erosion of our plaque, which is more of a chronic problem or happens over a longer period of time. Or the third thing that we can have is the formation of a calcium nodule. So like I said, the one we're going to focus on primarily is a plaque rupture, and that's generally what is going to happen when we see someone having an MI or even some bouts of unstable angina. So what happens is something occurs that's going to lead to this plaque rupture. Maybe that it's just too thin, and maybe the fact that now we have turbulent, non-laminar flow of blood going through this vessel, which is going to make the patient more hypertensive, and it's really going to cause detriment to this plaque. But whatever is happening, eventually what we're going to see is the rupture of this plaque. So we get a plaque rupture, and we see this fibrous cap open up. Now the thing with exposing this lipid-rich core and this calcified matrix to the lumen is that it attracts platelets, and that's one of the primary problems associated with this. So what we see when this fibrous cap opens up is we have platelet aggregation on the surface, or the calcium-rich surface. And again, we talked about it being sticky before and being attracting things like lipids. Well, it does the same thing with platelets as it's opening up into the lumen. So we have platelet aggregation. So as the plaque ruptures, we see platelet aggregation. Or adherence. We'll call that adherence. We see platelet adherence to our plaque. And as that goes on, what we have is basically stimulation of our coagulation pathway. So we have platelet adherence. These platelets are going to send more coagulatory signals, and we're going to get platelet aggregation. So those platelets send signals to other platelets, which is going to lead to platelet aggregation, or the formation or stimulation of that coagulation pathway, which is going to lead to many more platelets basically coming in as backup. So we start with platelet adherence, and we lead to platelet aggregation. Now this wouldn't be so bad if we also didn't have stimulation of the thrombotic pathway. So not only are we having coagulation playing a large role, our thrombosis pathway plays a large role as well, and we start to see fibrin adherence. So we start to see fibrin starting to lace itself into these platelets and form a fibrin mesh. Well, the problem with this is now we have clot formation. So very quickly we can go from a rupture of this fibrous cap, which is going to allow a small layer of platelets to adhere to the lining, to stimulation of both the clotting and thrombosis pathways, which leads to platelet aggregation and fibrin deposition. So now we have a clot formation. When we're looking at the others that we talked about, erosion of our fibrous cap, what happens is we just see small layers of this fibrous cap being ripped off, and we have a much slower progression to platelet adherence and aggregation. And the other one we talked about was the formation of a calcium nodule, which really is just kind of like we talked about before, where the lipids that get drawn in, is we get kind of a nodule of calcium and calcified, basically a calcified plaque forming on the outside of our fibrous cap. But in terms of acute pathology, what's happening in about 70 to 80% of cases is we're having the rupture of the fibrous cap, which is leading to platelet adherence, platelet aggregation, and fibrin deposition, which leads to clot formation. Obviously, you can see how this would be quite negative as we have the formation of a clot and disruption of blood flow.